Here we have seen the interface data type. So this data type is used for what? Completely decoupling, declaration and implementation. So we use this data type when we do not want to do any implementation at all. Okay, and we make others implement it. And who implements best? We can choose their class. Okay, it is used for setting standards, or it is used for setting, one more word we use, specifications. And interface is always used for setting specification. Okay, so you specify what you want actually, others will implement. Now who implements best? You can use it. So interface data type provides the highest level of abstraction. How? With the formula of AA is equal to new B, where A will be an interface and B will be, or B you can change it now, new C, new D, anything you can change. And these are classes which are implementing the interface. So before you write any program, okay, see generally you wanted to write logics in your life. So when you come to object oriented programming now, before writing logic, it is more important to choose the data type you want to write the code. Okay, simply if you want to write the, generally you have a habit, if I ask you to write some code, generally if I give you an assignment, you end up in writing what? First line itself, class A. That is wrong. You should never do that. Okay, so you should actually first decide, do you want to do a new, means if code is already existing, directly create an object and use it. If it is not existing, then what do you have to do? Now you have to think, do you want to do a concrete implementation, do you want to do a partial implementation, or do you want to do a no implementation? Okay, or you want to leave it open for implementation. Complete, go for a class. Okay, partial, choose an abstract class. No implementation, choose an interface. So if code is not there, if you want to write code, these are the three options. If code is there, you want to modify, what will you do? You can go for subclass. This is how they have designed the data types. So once you choose your data types, next you should know where to write the logic. Will you write it in a static block? Will you write it in constructor? Will you write, these are how things have been designed here. So writing logic becomes secondary here. You should know how to use your data types for programming first. Okay. Anyway, Java is very rich in data types. You have seen it is very rich in primitive data types also, and you have seen it is very rich in user-defined data types also. Very, very rich. So in Java, the user-defined data types, all the 4 user-defined data types can store value. Apart from that, they can implement oops. So powerful they are. In C and all, you have seen the data types. They can hold only values. They can only hold values. More than holding a value, they can, your structure, example, in C can only hold a value. But in Java, your class can hold what? Value. But apart from that, it can implement what? Oops. So rich it is. And at the same time, it is user-friendly. Your user-defined data in Java is user-friendly. You can work with it so easily. It is very difficult to work with what? Structured data type in C. But at the same time, it is very easy here. So they are rich, at the same time they are powerful, okay, and at the same time they are user-friendly. So that's the reason Java is becoming more and more popular. Okay, so now yesterday we saw the interface data type, and in the interface data type what I covered was the interface data type can contain only 2 members. What is it? Public static final variables and abstract methods. Okay, so are you getting the clear idea about all these data types now? So I'll continue that interface. Okay, and yeah, one last point. So you know how this data type gets the name now, interface? If you want to work with B object, I'm using this as the interface. Understood? Now we are using an interface. Now see, understand the English meaning of interface. And now you'll understand why the data type gets the name called as interface. First understand the English meaning. If you want to work with any complexity, example I'll tell, one more example we'll take. See, you know operating system. You know operating system is very complex. So it is installed on the hardware. Okay, if you want to work with the complexity of the operating system, what do you use? Use the Windows UI, user interface. So that is the interface to work with what? To your operating system. Without the, which one? You know, this is the UI, no? So to work with the complexity of Windows, what are you using? The user interface. We say no UI. So to always to work with complexity, what do we use? Interfaces. That's the general meaning of interface in English. This is very crucial statement what you have to understand. Okay, the meaning of interface, because that's how this data type gets the name interface. Okay, so you can see to work with the, see now the operating system has been installed onto the computer. To work with that, what am I using? I'm just using this UI now. So this is the interface to what? The operating system. See here, I'll work. Whatever I want to do with the operating system, I can work. In the operating system, I want to work with drives. I want to change some configuration, but I'm using this as the interface now. Same thing here. So if you want to work with the object, means object is nothing but what? Complexity, no? See, in English, if you want to work with complexity, they provide an interface. That is the meaning. In English, what happens? There will be some complexity. You want to work with that complexity, an interface will be provided to you. So here in this example, operating system is the complexity. To work with that complexity, we are using the screen as the interface. Same way, objects are what? Complexity. Why do you call them as complexity? They contain complex code. Understood? To work with that complexity, you might want to work with B object, or you might want to work with C object, or you might want to work with D object. That is secondary. But to work with that complexity, you are using this as an interface. So that's how this data type gets the name. Understood? That's how this data type gets the name, called as interface. This is very crucial. Okay, and it is because of this Java provides very high level of abstraction. Okay, so we'll be seeing now. See, Java is very rich in supporting OOPs, which no language can do this to this level. Okay, no language can support OOPs to this level. You are understanding what is OOPs now? Okay, we have seen it from language point of view. Later on, we'll be seeing it from programming point of view also. More things we'll see, then you'll understand that. Okay, so anyway, we'll continue. I'll continue with more of interface. So interface is one data type which provides very, very high level of abstraction. You always think about C++. C++, yes, how many data types are there in C++? Only 3. Class, subclass, abstract class and subclass. So you can see the level of abstraction, what you can achieve in C++ is very less. One data type only is not there, means imagine. So one, it is very less. And even though you design one data type there full-heartedly, means and work hard and design it, the problem with that data type is it's not reusable in any operating system. They stick on to only one operating system. But whatever code you write in Java, it will run in any operating system. So that is the level of reusability you can achieve in Java. Understood? So it's very, very rich. It is undoubtedly so rich. So it's only a myth created in the market like Java, difficult to learn and all that. Okay, so it's very rich, and at the same time it is user friendly also. Okay, so today I'll go with one more important concept. That concept is called as multiple inheritance. We have seen many types of inheritance. We'll see this first. See, remember this point in your lifetime, full lifetime you remember this. Interface was actually designed with one point in mind. Interface was actually designed for this purpose. You know what, for what purpose? To support multiple inheritance. We'll be seeing all the types of inheritance. But nowadays, I'm very clearly telling you, nowadays, actually, when it was first designed, interface, when it was first designed, it was used to support what? When it was first designed, it was used to support multiple inheritance. But today, we use it for what? Setting standards and specifications. This is the reason we use. Okay. Second, we use it for achieving. Use it for what? Achieving high level of abstraction and to support dynamic polymorphism. See, interface was designed with a different purpose. When they designed interface, they designed it for what? To support multiple inheritance. But today, we use interface for this purpose. Two reasons we use. Understood? So today we use this. Today, okay. So but when Java people designed it, okay, way back, 15, 20 years back, it was designed with this intention in mind. But today we use it for this purpose. So it takes some time for you to understand. Only examples are the solution for all these, statements and jargons. More examples you see, more you can understand. Yeah, more examples you can see, more you can understand. Let's start seeing now. So today the concept will be what? Multiple inheritance. Let's understand what is multiple inheritance. You know, this is one simple inheritance. Yes. Multi-level inheritance. Yes. Hierarchical inheritance. Java is supporting all these three inheritances. Yes or no? Java is supporting all these three types. How many types of inheritance are there? Simple, correct? See, we know there are three types of inheritance. There are many types of inheritance. So developers need support for this while programming. Understood? No? Developers need support for different types of problems like that. So let's see what are the different problems. Simple inheritance. Next one is what? Multi-level. Multi-level inheritance. Then hierarchical. Hierarchical. Then multiple. Then hybrid. These are the different types of inheritance. In simple inheritance, what will happen? There will be only one class and one subclass. Simple as this. In multi-level, what happens? A, B, C. You understood now? Multi-level. Hierarchical, what will happen? There will be one superclass but many subclasses inheriting the same class. Now we are moving into multiple. A, B, C. Now all this will be inherited into something called as D. This is multiple. And let's see about hybrid. So developer will have various kinds of problems while programming. So when he is having various kinds of problems, he needs the solution. Now who has to give him the solution? Language only has to give him the solution. So for all his programming needs, which language gives him the total solution, that one he'll pick. Understood? So simply you cannot choose one language. I'll learn Perl, I'll learn CJ, something like that. Always you should know the programming problems. When you know your programming problems, to suit your problem, which is the best language you have to choose. And at the same time, we are looking for one main important thing. What is that? User friendliness. Never forget that. Many languages came to support all this, but they are not successful due to the main reason, user friendliness. Understood? We know we can get the support of simple inheritance with superclass and subclass. How will you do it? Superclass, subclass. Java is giving intensive support for all this. This is the programming problem, and Java is supporting with what data types? For this you can use class, for this you can use subclass, it says. For this problem, yes, you can have superclass and then you can have a subclass. See how Java goes on giving you the solution for all this. Then it says, okay, if this is again, if you want, you can make this as, again if you want, a subclass can be what? Superclass again. So again this becomes the superclass for this subclass. It goes on. This is what is multi-level. Hierarchical. Okay, fine. So this is again superclass, and all this become what? Subclass. So you have got rich data types to support all your problems now. Okay, but now let's see how to do multiple inheritance. So developer is needing support for what even? Multiple inheritance now. Okay, so let's see how to do multiple inheritance now. Okay, so in Java, multiple inheritance is not supported. Remember this. It is not supported with three data types. Three data types. Which are the three data types which do not support multiple inheritance? Class, subclass, and abstract class. So these three data types do not support multiple inheritance. They do not. Okay, they do not support. Okay, or I'll write these three data types do not support multiple inheritance. Are you following? No. That is the reason when data type was required, which means initially when Java people were inventing the language, they wanted to give support for oops. They wanted to give the support for oops. And when they were inventing OOPs, they saw that multiple inheritance was causing major problems for the developers. I'll talk about the problems of multiple inheritance later. Okay, I'll talk about the problems of multiple inheritance later. Okay, I'll just show you now. It was causing too much of problems. That is why Java eliminated this. The support for what? Multiple inheritance. Means you cannot have just write three classes. Class A, class B, class C. There are three different classes. Example, you can write it today. Class A, class B, they are not related classes. Check this out. And class C. Okay, and try to say class D extends what? A comma B comma C. What is this? Multiple inheritance. Class D is extending what? This is the code I have written there. It will not allow you. This is what is multiple. So in other languages, most of the languages like C++, it is allowed. Okay, and I show you the problems. What are the problems you face in doing multiple inheritance? I show you. So Java observed all these problems. So they thought we will not support multiple inheritance. They did not support initially, but later on they realized the support was required. So they didn't want to change the behavior of these three data types. They let it remain as it is, and then they invented a new data type called as interface. Okay, so first when they designed the language, multiple inheritance was not there, and these three data types, they do not support it. But later on when they wanted to add it now, they realized again it is required. Developers were asking it. When developers start asking, their language has to support it now. Again, if they start remodifying these data types, people will find it very difficult to learn and again get adjusted. So they thought, let these three remain as it is. We'll introduce a new data type called as interface, and that will be supporting multiple inheritance. This is how they decided, and that's when they invented one data type which supports now multiple inheritance. They invented this. So that's what I told you before. Just I told you before this point what I told. One data type which supports multiple inheritance is what? Interface. So if anybody questions you, okay, does Java support multiple inheritance? What will you say? Yes, but complete the statement with the help of interface data type. Do not say no. Yes, Java supports multiple inheritance, but with the help of interface data type. That should be the answer. Do not say no. Okay, you should tell yes also, but don't stop. Continue the statement by telling with the help of interface data type. If you stop, that also will become a problem, because many people working now, they do not know Java supports what? Multiple inheritance. Many people working in Java, they do not know what Java supports multiple inheritance. So I told you so much now. Next, what will you ask? Example, sir. Correct, no? So we'll see with example now. So this is the story here. Okay. So initially these three data types were designed. They remain as it is. What you learned pays off. No issues, no changes. We have to see how to do multiple inheritance with interface now. Then again I'll come back to this entire subject. I'll cover interface today, and we'll see all the things now. Okay, what like today I'll be showing you multiple inheritance. Then I show you how to send it as argument return type. That is also very crucial. Once this is over, then we'll see what is the difference between all these four data types. We'll compare, and then we'll understand which data type to use when very clearly. Are you clear with this? So we'll see the differences between all the four data types. We'll see the differences. So shall I clear all this now? We'll go with multiple inheritance now. We'll go with multiple inheritance. Remember the point. This point you should never forget. Interface was designed for what purpose? To support multiple. Today it is used for what purpose? Dynamic polymorphism and setting standards and specification purpose. It was designed with this intention in mind, but today developers are using it for a different purpose itself. Understood? Okay, let's see it now. Shall I clear all this? So here what you will do now, sorry, here superclass, club, subclass and all now, here you can write, you will use interface, this one also will be what? Interface or class, either of it will happen. You can either use a interface or class. Means this D can be either okay, this D, A, B, C all will be interfaces. This D can either be what? An interface or a class. So this is the example I have to give you. Right now the example what I will be giving you is this example I will be giving you. Clear? Okay, we'll start seeing it. You understood now? These are all interfaces now. All this A, B, C will be what? Interface. Yeah? Okay. That example you'll be seeing now. See, first I'll have one interface here. Interface A, I'll have one method called as void M1, void M2. These are two methods. Interface B, okay, so I'll have void M3, void M4. Yesterday we saw an interface can extend an interface. That story is different now. These two are not related now. A is a different interface, B is a different interface. Totally they are different. Sometimes when you are implementing interfaces now, you can use only one class to implement more than one interface. This is possible. When you are implementing now, yesterday what was happening? One class was implementing only one interface. But there's an option for you like this. Class Z implements what? A comma B, highly valid code. This itself starts off multiple inheritance. Okay, so you're inheriting two features now. I told you, if top level are all interfaces, the bottom one can be what? Either a class or a interface. It is the same thing now. See, this is what we are studying actually now. Where will I? You understand now the diagram? A, B, C, D. So that is what I'm covering. Okay. So now see this. Class Z, it will implement now. So mandatory, it has to override what? All the methods. Mandatory. Mandatory, it has to override all the methods. Else this class becomes what? Abstract class. It becomes partial implementation. It is not implementing all the methods, it becomes partial implementation. As simple as that. So I can write SOP inside Z M1 and void M2. SOP inside Z M2. Then void M3. Extra members, you wish, your wish. If you want, you can have one member called as fun. So I'll write void fun. Extra member is your wish. But compulsory you have to override what? All the four methods of an interface. And remember, when you override for the methods of interface, all the methods should be what? Public. This is mandatory. Understood? Fun, you can have any logic. So here also you can print SOP inside Z M3, SOP inside Z M4. All valid. Now I cannot create an object of A, I cannot create an object of B because both are abstract, they are unclear. Or you cannot, other way you can put is, you can never create an object of interface. But definitely you can create an object of class Z. Yes, it is valid. Let's see now how do you create. See here, ZZ is equal to null. Yes or no? I can create this object, new Z. You can declare variable of all the three things. You can declare variable of what? Z class, A interface, as well as B interface. This is highly valid code. But you can create an object of only Z. But once you create an object of Z, you can refer it with what? Any variable, either A variable or B variable or Z variable. Remember this. Understood? So getting the point, one class can implement many interfaces. This itself multiple it starts off. And I have to explain it in a big way to you. Okay. So I can, which one I'll use? I'll use Z only. I'll use the Z variable itself to refer to this object. So now when the object is getting created, what are the members now? M1 and M2. From which one? A interface. Abstract methods. M3 and M4. From which one? B interface. Then M1, concrete methods. M2. Then what? M3. Then what? M4. Then if you are having extra, that is optional, fun method. So these are all concrete methods, and this is referred by which variable? Z. This is referred by which variable? Z. And now we can, with Z you can call all the members. See, with Z You can call all the members. Z dot M1 searches in the bottom, executes. Are you following now? Execution is same. What members can be accessed depends on the type of reference variable. Which one gets accessed depends on the type of object. That formula, never forget it. It will continue. Z dot M1, Z dot M2, Z dot M3, Z dot M4, Z dot fun. All the members you can access. Now if I say this is with Z, I will show you with A variable. How will you do it? With A is equal to Z. First give the reference of Z to A. After you give, again you can try A dot M1, A dot M2, A dot M3, A dot M4. Try A dot fun. So rule continues. M1 correct, M2 correct, M3, M4 wrong, fun also wrong. What members you can access from the object depends on the type of variable. Which member gets access depends on the type of object. So this is error. Correct? Now if you want, you can try it with B also. B is equal to Z, you say first. B dot M1, B dot M2, B dot M3. Try it today. See these mistakes, do it now, finish it off. In your lifetime you should not get these doubts. Get the errors, see the errors. This is last. Never make these mistakes again in your lifetime. Because this is last data type what we are studying. Understood? So M1 wrong, M2 wrong, M3 correct, M4 correct, fun wrong. So are you clear with how you work now? I am commenting it. Are you clear? So now this statement is correct. A is equal to new Z. This is also highly valid code. Okay, yes or no? Or B is equal to new Z is also highly valid code. But here the thing is, okay, 1 second. Even though A is equal to new Z, I can call only A dot M1, A dot M2. That's it. If I say B is equal to new Z, I can call only B dot M3, B dot M4. But both are valid statements. But no, if I want to access M3, M4 fun, typecast. Typecasting is possible here also. A can be typecasted to what? Either Z or B. Check out. Okay, A can be typecasted to Z. Okay, but you check out, can A be typecasted to B? You check out. That's the assignment for you. After many days I am giving a small assignment. Check it out. So this is valid, we know that. But the question is, can A be typecasted to B type? Understood? Check out. Understood? Definitely it is no only. So check out. Understood? A can be definitely typecasted to Z. Why you are typecasting? Same rule. What? To access subclass members. So you can typecast an interface also. Understand that. You can typecast a superclass, you can typecast an abstract class, you can typecast an interface. Okay, superclass also can be typecasted. Abstract class also can be typecasted. Then interface also can be typecasted. And we typecast all these three data types only for one simple reason, that is for accessing subclass member, no other extra reason. So you don't have to worry too much about typecasting. Typecasting of what? User-defined types. You don't have to too much worry about user-defined typecasting of user-defined data types. It is done only for accessing the subclass members. So this is possible. Here also, B can be typecasted to what? Z. So once you typecast to Z, I can call what? M1, M2, as well as I can call fun. Try this. Valid now? Here also, after typecasting to Z, I can call what? M1, M2, sorry, M2, M3, fun. Here I'll access what? M2, M3, fun. Here I'll access with Z what? Because here I am typecasting A to Z. With A I can access M1 and M2. So with Z I will access what? M3, M4, fun. Here with B I can access what? M3 and M4. I cannot access M1 and M2 and fun. So that's why I will typecast it to Z and access M1, M2 and fun. Are you clear with this now? So that's how it works. Are you clear with this basic thing? This should be clear to you. This is the first simple example for what? Multiple inheritance. This is only intro. Again we have to see more about what? Multiple inheritance. Understood? Again many questions will come out now. Okay. The answer for all that is again nothing but one more example. Okay. So when I show you something, some doubt, again the answer for that is another example. That's it. Nothing else. Are you clear with all this now? Okay. So I'll type this and show it to you now. So this is very important now. If you understand this, then other topics will start off about multiple inheritance. Shall I clear all this? Shall I clear all this? Multiple inheritance is a vast subject. Multiple inheritance is a vast subject, but we'll finish it off today. Even though it's fast, I'll accurately summarize it to the precise point. Understood? So which will be very helpful for you. You can have an interface. Let it say void M1. Okay, there are two interfaces, A and B. They are unrelated now. They are totally unrelated. Okay, you see, interface B extending A is different story, which I told yesterday. So now these two are unrelated. So when they are unrelated, what you do? Class Z implements A comma B. Highly valid syntax. Say I'll compile it. It compiles. Means it shows it is highly valid. The class is okay. It does not override. Okay, sorry. You have to override the methods. If you are implementing the interfaces, you have to override. But it's possible one class can implement two or more, any number of interfaces. What? One. Any number of interfaces your class can implement. Okay. So let's say this. Void M1. Again it should be, sorry, public void M1 Yeah, you can change the method names to M2 inside Z, M2, M3, M3, M4, this one also M4. Now this is the extra method what I'll have, optional, not mandatory, your wish. If you want to write an extra method, possible, write. See, done, all are comfortable, and for this no need of having public, it's your wish. For the extra methods which you give, it is your option to give the access specifier. Whatever you want, you can give. So it compiles. Now, all are three. How many data types are there? If you go and check, you can check A dot class, B dot class, Z dot class. Sorry, yeah, Z dot class. So those many dot class files will be generated. Even if an old dot class is there, it will be overwritten. Supposing yesterday I had called it interface A, that will be overwritten now. That's it. Understood? But anyway, how many classes in your file are there? Those many dot class files get generated. Fine. After this, what I'll do is I can declare the variables. See, I can declare the variables of all type. A is equal to null. B is equal to null. Then Z is equal to null. All are valid. So once it is done, see, it's compiling. Now object I have to create. I cannot say new A, error. I cannot say new B, error. But definitely I can say new Z. This is valid. But I will store the reference of this object into which variable I have to decide. And If I use Z, it is tight coupling. If I use A or B, it will be decoupling, and I can achieve dynamic polymorphism. So and that option you'll understand later, but let's work with what? Z itself now. Okay, so when to create which object and when to use which variable will come to you with experience. Okay, when to create subclass object, when to use superclass variable will come to you with experience. But let's learn how to work with superclass variable also, subclass variable also. Decision about when to use which variable, it will come with experience. First let's learn this. So now when I do this, Z is equal to new Z, what all will happen now? Z dot M1, Z dot M2, Z dot M3. With Z I can call all the members. Z dot fun, Z dot M4 no, 1 second. See all the methods you can invoke, compiles, and all methods are getting executed. With Z I can do this. Okay, now you comment with Z and we'll try it with what? We'll try it with which one? A is equal to Z. See, this is implicit casting. A is equal to Z is nothing but what? Implicit casting. Because you are giving the value of subclass to superclass. Understood? This is implicit. Whenever superclass variable is referring to subclass object, it is implicit casting. Understood? When you want to give the value of superclass to subclass, see here what's happening, we are giving the value of subclass to superclass. This is implicit. But sometimes what will you be doing? You'll be giving Z is equal to A, means A value. Right now that's not the case. A value will be giving to Z. That is when you have to do typecasting. Understood? This is called as explicit casting. Remember that. And so explicit casting is only done for one main reason, that too of user defined type, to access subclass members. We'll see that point later. We are right now going with A is equal to Z. Okay, A dot M1 done, A dot M2 done, A dot M3. Now let's see what error you have. Let's find it out later. A dot M4 and finally A dot fun. You should get errors. So you cannot learn programming without errors. Man, remember one point, man always learns from his mistakes only. Without mistakes you can't learn. Commit. So now we have done so many mistakes. What are the mistakes you have done? M3, M4 fun, very clearly it shows. So who is the best trainer, me or compiler? Compiler, see? Correct, no? So in spite of this much of effort, he'll give credit to compiler. Fine, no problem, learn it from the compiler itself. M1 and M2. Are you clear with this? Okay, fine. Next, with which one we'll see now? B also you can try it out. What? B is equal to Z. This is also valid. Again with B. B dot M1. B dot M2. Fine. B dot M3. B dot M4. B dot fun. Fine, let's compile. Compiler again gives errors for M1, M2 fun. So these errors you should never get in your life. This is at last. You should know what members you can access from our object. In accessing members you start creating mistakes now. Now nobody can save in object oriented programming. Understood? So you should always know which member you can access, how to access, and which one gets executed also. So all this while I was teaching you that only. Which member you can access, how to access, which one gets executed. Understood? Because we have completed data types. Now we'll start using the library. When I start calling the methods now, you should know now which one is getting executed, from where it is getting executed, why it is getting executed. So there all these basics will be applied very powerfully. Understood? We'll start using the library now. We are completing this. Okay, by today, tomorrow all your data types will be over. Understood? So that is when you should be very accurate about all this. So here that's why I'm stressing more on all this now. It looks like M1, M2 are very simple and you can by heart it also, but do not by heart all this, because in libraries you can't by heart. You should understand it in a logical manner. So now it again compiles, it works. Okay, M1, M2, okay, that is from which one? M1 and M2, okay, A object, fine. So if you want only with B, see this, it will execute only M3 and M4. Okay, finally if you want explicit casting also, I'll show you. So now I will say AA is equal to new Z, valid. But with A I can call what? A dot M1, A dot M2. This is valid. Sorry, I have declared all that interface again on the top. Okay, I'll do one thing. I'll remove that A. We have declared it. We'll comment of this Z object. We'll comment of this A variable. Just assume that, okay, or I'll cut this and paste it there itself. So this is the story. We have created the Z object. Understood. So here everything is fine. Okay, here. So here, okay, everything is fine. I have created the Z object. I am referring it with A. But problem is I can call only two methods now. So if at all you want to do it now, what will be the problem now? You have to give the value of Z to A. Yes or no? So you are trying to give what? Bigger value to smaller data type. So what you have to do? Casting. So here you have to do explicit casting. Otherwise it gives you error. Yes or no? Explicit casting you have to do. So this is error. This is error. Okay. So I'll comment this off. Why it is error? Because you are trying to give a bigger value to smaller data type. So what you have to do? You have to typecast. Correct, done? Okay, Z has to be in brackets. Explicit casting means this is again, remember that, casting interface. Yes or no? Interface data type. You can cast superclass, abstract class and interface. You can do typecasting of, means this is called as what? A downcasting. Sorry, you're downcasting. Here for user defined type, casting is called as upcasting and downcasting. Here we are downcasting it. Why are you downcasting? We are moving down the hierarchy here. Okay, we are from A, we are going down to Z, and we do this only to access subclass members. No other reasons. Now with Z I can access what? I can access all Z dot. See, with M1 anyway you can access with A also. Z dot M2. These two I can access with A anyway. There is no doubt. But main reason why I typecasted was to access what? Z dot M3. See, I can access M3. Z dot M4. Yes, I can access M4 as well as I can access Z dot fun. So I'll comment these two now. Okay, and now you can see all methods are getting executed. And you know why this is error now? You are giving bigger value to smaller data type. Means, are you clear? Again, and this is explicit casting, or also it is known as another word, down casting. Implicit casting is known as what? Yeah, this is implicit, or also known as upcasting. Do not forget these two terminologies. Upcasting means moving up the hierarchy. Downcasting means moving down the hierarchy. Very simple. Up the hierarchy, down the hierarchy. Means if you give the address of B to A, upcasting. If you give the value of A to B, downcasting. Very simple. Clear? Upcasting is implicit. This one is okay. So fine, all this is over now. So it will execute. Now the next thing what you have to learn is what? See, always when you observe something in the program, comment. Like see, while teaching also, I didn't come prepared. You can see, I'm taking this class fluently, and as I go on typing this, I'm explaining the statements like this. So this is how you have to go on commenting what you observe in the program. Okay, which will be very helpful for you in the further stages. While learning, you do this. Understood? Are you clear? So then next, can A be typecasted to what? You can typecast it to Z. This is okay. But let me typecast it to, let us try doing it. Okay. Which one? To B. This was a case now? Yes, let's see what happens. It's working. Sorry. You can cast it. Sorry about that. Understood? But they are not related. I will explain to you that. I can access what? M3. No, null pointer exception. Okay, B dot. I had a doubt about this. Yeah, it is executing. Understood? See, I have created an object of A, but you are typecasting it to B type. A and B are not related. Huh? That is related to Z. That's why it can be typecasted. That is related to Z. Okay, in Z, see, either you can do it like this. A can be casted to Z, and the value of Z can be given to B, no? Think it in that way, no? A can be casted to Z, and then you can give it to what? B. Very simple. Instead of that, you are bypassing. See, A can be casted to Z, you know very well. Once it is casted to Z, I can say what? BB is equal to Z is valid, no? Yes or no? Getting the point? See, I have said AA is equal to new Z now. Okay, now to access subclass members, I typecasted it to Z. But after typecasting to Z, I can do this. BB is equal to Z. This is also possible. All the three types of variables can refer to the object. Remember that. A also can refer to the Z object. B also can refer to the same object. Z also can refer to the same object. You have got an object here now. What is the object? We are having M1. This is abstract method. M2, M3, M4. These are all abstract methods. These are the members of interface A. These are the members of interface B. You are having M1, you are having M2, you are having M3, you are having M4, and you are having fun. So to this object, what are the different variables which can refer? Three types of variables. That's it. Okay. So after I say this, now A is referring to that. The same address I can give it to what? Z. Now after that, Z value I can give it to B. Instead of this, we are bypassing these two lines and directly I can typecast A to B now. Valid. So this is where confusion start off in multiple inheritance. Multiple inheritance is the toughest subject. Understood? Actually, you'll go mad while learning multiple inheritance. Understood? And Java supports this elegantly. I'll show you how it goes on supporting this to a great extent. It is impossible to learn multiple inheritance in C++. Understood? Finally, you'll quit learning inheritance only in what? C++ and somehow you'll start managing. But here it is accurate. This is how it happens. This is how it happens. So this is one simple introduction what I've told. We'll see more examples. So this is possible. Initially I told, I'm sorry about that. Initially I told A cannot be casted to B, but I'm clearly telling A can be casted to B. Clear? Clear this? You have understood the rectification? Huh? Okay. Clear this. Then next. This is about multiple inheritance. Clear? Shall I clear all this? Any doubts in this example? This example? Extra doubt not ask. I'll clear now. In this example, you have any doubt? Ask. Because next example, I know what are your questions. I already got the answer for it. Understood? Any questions in this example? No? Okay, we'll continue. See, sometimes when you are doing multiple inheritance, there are some problems we face. Let's see what are the problems. Okay. One of the problem would be interface A is there, void M1. One second. Yeah. Void M1, void M2. There are two methods, or I'll take this as fun method. There is a method called as M1 and fun method. Now interface B is not related with A. It goes on to have an extra method, void M2, and again it has one extra member called as fun. Now see, interface A is having one M1 method, fun method. Interface B is having M2 method and fun method. You understanding the scenario now? Yes. Now class Z decides to implement what? A and B. It is possible. But now interesting things will start happening here. Class Z Now this is where all your doubts will start arising. Understood? This is where all your, you don't have to question also. I'll complete all your doubts. Just keep on observing now. I know all your doubts. Implements A comma B. Understood? So next, what will Z do now? It has to give the body for methods of which one? MA first. So it you are giving now SOP inside ZM1. Then next, you have to give the body for fun also. You have finished giving the body for which one now? A interface. You have finished giving the body for which one? A interface. Next you have to give the body for what? B interface. Okay, so you will give the body for M2. Means you make it as public, man. This is common now. As I told you, I might forget. You make it as what? Public. When you are overriding, make this as always public. So you are giving it for M2 also. Extra method is optional. You have it. That's your option. The most important thing here is, for fun also you have to give the body of which one? Interface B. Yes or no? But you cannot have separate implementation for both. It will be a common implementation for what? A and B. So fun is going to be a common implementation for either A, for both, or B. It's a common implementation. So you can't have separate, say in the previous example you saw I had M1 and M2 in interface A, M3 and M4 in interface B. So when class was implementing those two interfaces, it was overriding 4 methods. But now I am overriding 3 methods. Are you following now? Why? Because this is going to be a common implementation for interface A and B. You understanding what is common implementation? And you know how it works? Same story. With A, I can call 2 members. Which one? M1 and fun. With B, I can call what? M2 and fun. With Z, I can call what? All the 3 members. But are you understanding what is common implementation? Casting is again possible. Understood? So here the story will become like this now. Class demo PSVM. Okay, see, I can have a reference variable of all the 3. A is equal to null, B is equal to null, Z is equal to null. Valid. Okay, now I'll say new Z. I'm creating an object of what? Z. I'm creating an object of Z. Once I create an object of Z, that can be referred with Z or A or B, that is secondary. Okay, but let me create the object of Z. See, these are the methods of M1 and fun. Okay, in fact, it's better I show multiple inheritance in this way now, rather than taking one object like this. It's, see, what diagrams I draw is only pictorically for you to understand the members. Okay, in JVM they are represented in a different way, remember that. Understood? So here also I'll show it in this way now. See, this is M1 and fun of interface A. This is M2 and fun of interface B now. This is interface A, this is interface B. And now Z will have the implementation for what? M1, M2, fun. So this is the object which has got created. Are you understanding? It's only to make you understand the members. So these are the members of Z class. So now see, ZZ is equal to Z dot M1. It will get accessed. Z dot M2. With Z you don't have any issues. Now I'll do casting. Implicit casting. With A I can call what? A dot M1, correct? A dot fun, correct? A dot M2, error. Same way. B is equal to Z. B dot M1, B dot M2, correct? B dot fun, correct? B dot M1, error. Casting and all is possible. But you understood what's common implementation? You cannot have separate implementation. I might have a question. How to give separate implementation? My answer is you cannot give only. You cannot give a separate implementation for fun now. Because see, you are overriding. Everything is same now. If you wanted to give separate implementation for that method, what will you do now? Your question might be that. Only option is either you overload. Now what you have to do? You have to give the body for that also. Either you overload. But simply you will not overload. Remember, the functionality is same, you will overload. Understood? Next. Or you give a different method name like test. That's your wish. But you can't have a separate implementation for the same method name. It is impossible. Understood? Now you might have, this is, just start thinking this properly, it will help you ahead in the next example. You understood what is common implementation now? Common implementation. Okay, when the method names are common in two interfaces, you cannot have two separate implementations. Understood? You cannot have. Either you overload it or give a different name, and you know when to overload and when to give a different name. Overloading is done when functionality is same, and when a new method name is given when you want to write total new functionality. That's your wish. Are you clear? So, but you cannot have a different implementation. One more thing. What happens if I have a common implementation? You can ask. Means what happens if I try to write a different implementation? You might ask. If I try to write, example, see this, class Z implements AB. I am writing M1 and fun for which one? A interface. For B interface I am writing M2, correct? And I am writing fun, and I will write here SOP Ravi. It's a different implementation. Ravi cluster, something like this I am writing, some logic, different logic. Correct now? But in the same scope, can two methods have same name? No. Very simple. Scope. So you cannot have two methods with everything same in the same scope. So that is why it gives you error. It will always give an error. If you try to do it also, it will give you error. So this is what is meant by common implementation. Are you clear with this? And once it is common, same method is accessed by what? A also, B also. Remember that. From A also you are accessing the same method, from B also you are accessing the same method. It will not be a different one because there is only one method. You want me to show this with coding? Clear now? Understood the concept now? Yes. So this is how when conflict with methods are there, you will resolve. Any questions here? Now, are you clear? Okay. Now I'll go with variables. Supposingly x is equal to 1, int y is equal to 2. First I'm showing different variable names. Now how do you work with this? With this x and y? See, you can work with x and y with any way. You can also say a dot x or variable name dot x. Correct now? You can access it like this. Similarly, you can say b dot y, SOP you write. So you can access it because they are static variables. You can access a dot x or SOP a dot x. Similarly, you can print SOP b dot y or SOP variable dot y. Two options. Or you can also say z dot y. You can also say z dot x or z dot y, class name dot. Similarly, I can go with what? Variable name dot, z dot x, z dot y. These are all the possible options you are having. See, with A I am accessing, with B I am accessing x and y, and with z I am accessing. With z you can access it like with the class name also you can access, or with the variable name also you can access when they are different. Or after creating the object also you can access it here. Static variables come into existence as soon as the interface is loaded into the JVM. You know, class loading stage now, same. Are you clear with this? So you can access it wherever you want, however you want, whenever you want you can access. Are you clear with the variables? Yes. So but when there are two interfaces and when there is conflict like this, what is happening now? Same name. And according to scope it is allowed. Yesterday I told you one point. When an interface is having a variable, same variable is inherited into what? The class implementing the interface. That's the example you saw now. Z.x, Z.y, how did you get it? Actually they are the variables of interface A and interface B. So since Z is implementing which one? A and B, with Z also I can access what? X and Y. Yesterday I told you this. If any class is implementing an interface, all the variables of an interface are inherited into the class. Same story. But now the thing is, the variable names are same now. Variable names are same. Value is different. Notice. In 1x the value is 1. In 1x the value is 2. Understood? Now how will you work? Question is that. This is correct. Either you can work with interface name or you can work with B also. But this will give you error. Means see A dot x no issue. Understood? B dot x also no issue. No, not y now. Both are x. A dot x also no issue, B dot x also no issue. But Z dot x, which one should it print? It is inheriting both. So this will give you error. Ambiguity problem it will tell. So now how do you access it? With Z you can't access. Very simple. When there is conflict between the variables, you cannot access it with Z. You can only access it with the interface name. You have to, till now you are accessing it what? With class name also. But now you cannot access it with class name, you have to access it with interface name. Okay. And here also see, in M1 class Z is implementing AB. If they were different, I could have used both. SOPX also I can use, SOPY also I can use. In the class implementing the interface. In M1 is a method of what? A. But M1 is a method of which one? A. But in M1 method I can access X also, I can access what? Y also, both. Both I can access. M1 is a method of A. Why? Because class Z is inheriting both the features and I can access it. But if both are same, now SOPX will print what? Error. So here also that time you have to go with what? You have to go with the interface name only. A.X, B.X. See, if they are different you can use like this. See, one I am telling you, see, look carefully, observe where and all I am accessing that variable. One, I am trying to access that variable in the class implementing the interface. Observe that first. One, I am trying to access the variable in the class implementing the interface. How do you access the variable in the class implementing the interface? Directly you can access. Directly. Understood? SOPX, SOPY, provided there is no conflict. You can access it directly without any interface name when there is no conflict. But if there is conflict, you have to access like this. Where? In the class implementing the interface. Are you understanding this scenario? Okay. Now, I am not accessing the members now. You leave there accessing now. Come to demo class. Now, demo is not at all related to those three things now. Don't see it as main method. See it as a totally different class. Now, don't see demo as what? Main function. See it as a totally different class. So, when you are trying to access those members in a totally different class, how do you access it? That's the next question. Okay. The answer is, you can access it with the interface name A.X. Only one variable now. B.X. Correct? Or Z.X is error. So you should know in the class implementing the interface also how you are accessing, and in a different class also how you are accessing. Are you clear with this? So multiple inheritance, you understanding the problem with only two interfaces. Now if I bring 3, 4, what will happen? Let's see. So how Java gives the answer to all these problems, we'll see it. Are you clear? Shall I clear this and type both the things? So I'll be typing this program because it will show you clearly the meaning of what is common implementation for methods, and also I'll show you how to resolve the conflict when there is between variables. Understood now? It's a very crucial program, okay, which gives you a clear idea into what is multiple inheritance. Clear? Shall I clear this program? And remember, X is here now for your information. Means actually it will not be here, it will be in the stack. But one is X is belonging to A, another X is belonging to 2. These two are inherited into Z. In Z, when there is conflict, you have to use it with interface name. Understood? When there is conflict. If they are different, directly you can use what? In M1. SOPX also you can use, SOPY also I can use. Understood? First I'll show you without conflicts, then I'll show with conflicts. Shall I clear all this? We'll go and typing the program now. Okay. If you get this point, you'll understand multiple inheritance completely now. This is a very simple example for it. I'm clearing everything now. Class conflict members demo means we'll have a conflict members demo. Understood now? First I'll complete of methods, then I'll come to variables. Conflict with methods we'll see, then we'll come to variables. So we are having common methods here. Done? So now next, when class Z implements, you know one class can implement more than one interface. Yes or no? Yes. So when it implements, what it has to do? Override both the methods. Yes? Override all the methods. Extra method is optional. Leave it. So I'll write M1 and fun for this. So next I'll have M2. Fun is going to be common now. Check this out. When I compile, it will not give me error. Otherwise compiler would have told me no, give the body for that abstract method. If you don't override the abstract methods of an interface, it would have told you what? Override. Actually there are 4 methods, but I'm overriding how many methods? 3 methods. Are you following now? So next what will I do now? I can create the object. Which one you want? Z is equal to new Z, and I can call all the 3. Z dot M1, Z dot M2, and I can say Z dot fun. Done. All this you don't have. Okay, I didn't change the output here. M2 and fun no, and M2. This now it will print all the 3 methods, M1, M2 and fun. Okay, this if you want, see, you can also say A is equal to new Z, A dot M1, A dot M2, M2 is error, A dot fun. So M2 will give you error. Check this out. So I'll comment M2, Z and M1 and fun. So next I'll say what? B is equal to new Z, B dot M1, B dot M2, B dot fun. Which one is error now? M1 is error. So 2 methods it's printing from A, 2 methods it's printing from B. That's it. So fun is a common implementation. You can see it's not changing any logic. Are you clear? You understood what's common implementation? You typecast and check, do whatever you want. Understood? So it will execute the same method. Okay, next I'll go with variables. See here, int x is equal to 10. Now in this one also int y is equal to 20. I'll show you without conflicts first. Int x and y I'm showing you without conflicts. So now say M1 in Z, where? M1 in Z, okay, can access what? Both x and y. See now I'm trying to access those values in the class implementing the interface. Value of x is plus x, value of x in Z is plus x, value of y also I can access. See this, so you can access both from A and B, both you can access it in this one. And I'll try to call the method. Now I will call it from anywhere, no problem. I'm calling M1 method now. Are you following now? A is equal to new Z. I can access it. See, I can access it in Z class when they are different. Okay, here I can access. Now let's see how you access it in another class when they are different. Now I'm trying to show you how to access the members when they are different in the class implementing the interface. There you can access. How do you access it here now? Here many ways are there. think I'll comment all this. See here, plenty of ways are there. We can start off from here. Value of x in demo classes. I'll access, say this, a dot x, a dot, sorry, b dot y. I'm accessing it what? See, I'm accessing it with interface names. First check. Yeah, that's possible. I can access them with variable names. A is equal to null, B is equal to null, so now I'll access the same values with the help of what? Variables. So B dot y, A dot x. Perfect. And definitely I can access them after creating the object also. Z is equal to new z. Value of x and y in demo class with z is, you're following now? With z is z dot x, z dot y. Are you following now? So, or I'll just make it in demo. I'll just remove this class. It will have a clear vision. Clear now? You can see it now. Very clear. I can access it with all the three strings. See here I'm accessing it with interface, reference variable. Here I'm accessing it with z object. Not only with z dot, I can access with z class dot also. Capital Z class. Okay, that also if you want to see. After creating the object also you can access, or with the see all these ways you can access. ZS. Okay. So it's possible. Are you clear? Look how you are accessing all that. Fine then. But if there is ambiguity, now it will start off. Now it will start off. So first you cannot access it where? In the class. See here, it gives here. I'll comment off all this 1 second. First we'll resolve there and come. Yeah, now we'll compile. So it says reference to A is ambiguous, both variable in X and A variable in B match. So this error I am getting for what? See this carefully. I am getting this error for line number 19 and 20. So where are these problems? Line number 19 and 20 means these two. So here is the, sorry, here also I have to change it to what? X, sorry. Now we are printing 2x, but what it thinks? It will have problem. So both are same, it will tell 19 and 20. So what I should do now? Yes, it is possible to resolve, but with reference dot, sorry, interface name dot. Now it will work. Pretty clear. Clear? Now that's how you resolve there. Now if it is here it will work, no issues. Now where it will work? A dot x, B dot x means with the interface name it will work. Variable name it will work. Are you following now? Here also it will work. All these 4 statements in another class. See, that was in the class implementing the interface. This is in another class. Another class also this is fine, no issues. They are two separate entities, understood. But with Z, you'll start having problems. You can never with Z. You can never. Okay, see, I'll comment this Z dot x, Z dot y I'm commenting. And I'm just showing you with object dot x and one more is class name dot x. Both will give you error. So I'll comment this one. So this is not possible. Again it gives you ambiguity here. Are you clear this? So this is how it happens. Clear? Okay, so you should know how to work now. So then more about multiple inheritance now. Okay, are you clear? These two interfaces. Okay, now more we'll see. See, this is also possible. Just remember this. Today you try doing this. Interface A. I've shown you two interfaces. Okay, see this now. Void M1, or we take it as A1 method. Method name I'll take it as A1. And this one will be method name as A2. You can give any name, but it will be simple for you. Void A1, A2. Then I'll take interface B. Void B1. Simply you print inside B, some methods you print inside, something you print, that's it. So this is two interface. But take one more, interface C, void C1, void C2. Then you take interface D, they are all unrelated, notice that. You can take void D1 and you can take void D2. Now you know, you can write class Z implements what? A, B, C, D. How many ever interfaces you want, you can implement. First try this. See, write this. Class Z implements what? First you try this example. Understand now which example you have to try? Class Z implements A, B, C, D. And you have to override all the methods. First work with this. There is no conflict here. Don't create any conflict also. Is there any conflict with the method names? No. If you want, you can have different variable names also. Here you have int p. Just try to work. Here you have int q is equal to 2, int r is equal to 3, int s is equal to 4. And you work. Understood? Class Z is implementing what? A, B, C, D. Z dot p I can access. Z dot q I can access. Z dot r I can access. Z dot s also I can access. Similarly, Z dot A1, A2, B1, B2, C1, C2, D1, D2, all the methods I can access. If I try to work with A, only two methods, A dot A1, A dot A2. Understood? A dot P also possible. If I try to work with B, B dot Q, B dot B1, B dot B2. You know how to work now. Are you clear with this? Fine. This is what is multiple inheritance. One good example. One more terrific example for multiple inheritance we see now. What is that, you know? This is class Z. Now see here. Interface Z extends, carefully see now. Extends A, B, C, D, valid. Highly valid. This is multiple inheritance, yes or no? This is not possible with the class. If all were classes, this is not possible. But multiple inheritance is possible with the help of interface data type. Possible. So you can add one more extra method here. That is optional. That is optional. When interface Z is extending A, B, C, D, extra method it is adding two methods. Which are there? Void fun, void meth. See, this is example number 1. This is example number 1. First finish this. Now this one would be what? Example number 2. Understood? So this is example number 2 now. Carefully work with both. Okay. Now again, if this is the case in example number 2, I cannot create an object of A also, B also, C also, D also, Z also. So what I should do now? Class hello. I can say, a second. See, this is how you write. Class hello implements what? If you say Z over, implement Z means how many methods you have to implement now? Methods of A, methods of B, methods of C, methods of D, methods of Z. So totally you have to implement how many methods here? 10 methods. You have to implement 10 methods. You know which one now? A1, A2, B1, B2, C1, C2, all methods you have to implement. D1, D2, fun, meth. Because I am implementing which one now? Z class, Z interface. Otherwise, it is my wish. I can implement only A also. That time I will override only 2 methods. Okay, I can say A, B. That time I will override 4 methods. I can override A, B, C. That time I will override 6 methods. That if I implement A, B, C, D, 8 methods. Okay, otherwise if you want to implement all, but this is multiple inheritance. Are you clear with this? If there is any conflict with variables, you know how to resolve? Okay, and if there is any conflict with methods, common implementation. You might have example, you might have one method called as cluster everywhere. Void cluster is the name of the method. Understood? Void cluster you can have. For everybody it will be what? Common implementation. When there is conflict in methods, it will be a common implementation. Understood now? So instead of writing 4 times cluster method, you will write only once. That's it. Clear this? One of the toughest subject in OOPS is inheritance. Encapsulation is not difficult. Polymorphism is not difficult. Is there any difficulty in encapsulation? Encapsulating everything within a data type is called as what? Encapsulation. Polymorphism, one name, many form. Either you can overload or you can override. That also simple. Criteria for overloading is number order data type. Criteria for overriding is object. Then abstraction also very easy. The toughest is inheritance. The toughest is inheritance because there are many types of inheritance and we need a solution for all these types of inheritance. Understood? Like simple, what is that? Multi-level, hierarchical. Now we are seeing what? Multiple inheritance. Now we are saying multiple inheritance. Are you clear with all this? Now I'll explain you problems with multiple inheritance. Now all your doubts will be cleared. I know what are the doubts you're getting and all your doubts will be answered in 10 to 15 minutes now. Understood? Let's see now. First we'll understand the problem and now you'll get the exact reason why in Java interface is allowing only two data members. Only two types of members. Public static final variables and abstract. Now you'll understand very clearly. Yesterday you might have a question. Why it is allowing only two members? What's so special? Now you'll get the clear idea. Understood? So I'll explain you first problems with multiple inheritance. And then we'll see how Java is resolving all these problems. But till here everything is clear now. What is multiple inheritance? Can you do this assignment? Try it out. If you are not comfortable with 4 interfaces, at least try with 2 or 3 interfaces. At least try 3 first. Don't directly code 4. First 3, then 4, then you try 5. No issues. Yeah? I clear everything now? So here it was class hello. Remember that. Implementing Z. Remember that. Understood. And you have to create object of hello class. You know how to write the main code now? Main code you write. For both the examples you check out now by writing the main method. See, first let's understand the problems with multiple inheritance and how Java overcomes the problems. Problems with multiple inheritance now. Okay. See, generally to understand this topic, again you have to go back to the members. What are the different members you have in you can have in a class data type? Instance variables, static variables, okay, constructors, static block, instance block, methods, concrete methods, static methods, correct? So these are the different members. Now, one by one we'll take the member and we'll start understanding how it causes problems in multiple inheritance. In fact, all these members which are instance variables, concrete methods, constructor, blocks, both blocks which are static and instance blocks, all these members cause problems in multiple inheritance for you. All these members. Okay, let me show you. So problems with inheritance, all these I'm telling you what now, all these members cause problems in multiple inheritance. Now you might have the next question now. How? Give an example. Obviously when I tell some topic you will be telling that only. Make me understand the topic with what? With an example. Same thing. Now again we'll go with one more example now. See, first I'll show you problem with methods. First I'll go. Problems with multiple inheritance. The first problem I'll be going with what? Problems with methods. Problems in multiple inheritance. First one with what? Methods. First I'll go with method. See this. Supposingly class A is there. I'm going with class. Class A, void M1 is there, void fun is there. Okay. SOP AM1, SOP inside A fun. Next, class B is there, void M1 is there, sorry M2, a different method, void M2, a different method is there, but again it can have the same method name, yes or no? Now this is not overloading also, this is not overriding also. This fun what you are seeing here is neither overloading nor overriding. Why? Because it's in a different class. Not related only. Neither it is overloading nor overriding, but definitely I can have it. So I can have many methods with the same name in different classes also. Like this. Now let's see. If I try to do multiple inheritance, what happens? With two classes I am showing you. Supposingly, class Z extends. I'll write this code that side. Class Z extends which one? A comma B. It can have an extra member. Now where will I write? Are you following now? It is extend. No, I can write it here itself. Class Z extends A comma B. It can have an extra member. Like example, void meth. That is optional. Leave it. Having an extra method in Z class is optional. So I have written it now. So I'll write class demo, and I'll create the object of which one? ZZ is equal to new Z. I've created the object. Once I create the object of Z, you know the object of Z gets created. What are the members of Z now? M1, M2, sorry, M1 and fun from which class? A class. Okay. M2 and fun from which class? But remember they are in the same hierarchy. Yes, don't draw like this, just draw it like this. In multiple inheritance it's better you draw like this. See, M1 and fun are from class A. M2 and fun are from class B. Now, meth is an extra method from class Z. That's how it is. Now, I have created an object of Z. Z dot M1 it can execute, no issues. Z dot M2 it can execute, no issues. Z dot meth also it can execute, no issues. But Z dot fun, which one it should execute? Preference should be given to which one now? There are two methods now in Z object, and both are concrete methods. Both are concrete. So should it execute inside A fun or B fun? So this is problem with two classes, remember. Understood? You might have more, A, B, C, D now. Now it becomes headache. Okay. So sometimes by chance, Z dot fun, if you tell it executes the method from A. Now here I want to execute the method of B. Definitely it will happen now because you want to reuse the logic. One method you want to call somewhere else. How will you go on tracing now? Which one is getting executed? We go mad actually. Literally you can't trace, and we start finding problems in what now? Inheritance. There are only two levels. I can go more. Class C, again void M3. SOP inside M3, leave this one. Void fun. SOP inside, sorry, B fun you write, B fun. SOP inside C fun. Now, if it is extending ABC, which fun should it execute? Problems will start off. It's very difficult to trace now. Supposingly if it executes fun in A. Now fun in A wants to, I'll call Z dot fun. It is calling which one now? See, this is of C now. One more fun class as I got added. Now how will this fun invoke the fun of B? How will this fun invoke the fun of C? If it required, I'm telling you. So now it becomes very confusing. Which fun is getting executed, you'll fail to trace also. This is to one level. Understood? Now see, more complications will start off. What I'll do, just see this now. Class A1 extends A. More conflicts. Void fun. Overriding. I don't want the logic. So fun has been overridden in what? A1. So if this is the hierarchy, it is very neat and clean. A means class A1, sorry. One more class name it is. A1 is equal to new A1. Which one gets executed? Fun of A1. Overriding. This level. Multi-level. Understood? Supposingly I have class A2, which is again extending what? A1. So totally in A, in this hierarchy there are 3 fun methods. Next, same way, class B1 extends what? B. You will override what here? Fun here also. Class C, B2. You can override here also. Same way, class C1 extends C. You will override here also. Class C2 extends C1. You will override here also. You know hierarchy now. C2 is extending C1, C1 is extending C, B2 is extending B1, B1 is extending B, it is extending A1, A1 is extending A. Now, this fun is there. Class Z extends what you know? A2, B2, C2. Now dead. In A series there are 3 methods, fun methods. In B series there are 3 fun methods. In C series there are 3 fun methods. Among 9 methods, one will execute, agreed. Which one from where it is executing? That's the problem now. Okay, again someone gets executed. From that method, see, supposingly, fun of A2 gets executed. But I want to invoke from here, fun of C1 fun. Supposingly when I say Z is equal to new Z, Z dot fun if I say, understood, Z is equal to new Z, Z dot fun, among the 9 methods, this one is executed. But from here my requirement is what? I want to invoke the fun of fun in C class. How will you trace now? From there I want to invoke this fun. Which one? Fun of A class. Like this, tracing becomes very difficult. Okay, multiple inheritance is a big headache for the developers. Simple inheritance okay. Which one? Multi-level okay. Hierarchical okay. But this one is very, very complicated. Which one? Multiple inheritance. Are you clear with the problems with the methods? So that is why Java eliminates concrete methods in multiple inheritance. It eliminates. So that is why in interface what's happening? Did you observe? We had only abstract methods. We didn't have concrete methods. Understood? That is why I say interface is a data type which is supporting multiple inheritance. So whatever members are causing problems in multiple inheritance, Java is eliminating those members in that data type. Which data type? Interface data type. Now why they are eliminating those members in interface data type? Because it has to support multiple inheritance. Understood? That is why they did not change the design. Which one? In class, subclass, abstract class. See, this is the difficulty what you face in C++. In C++, where developers are finding difficulty in inheritance. So you can observe now. In C++, what all is bad? Inheritance is very badly implemented. Why? They have a solution to this. They have something called as friendly functions. Some solution is there, but it's a very complicated approach. Having concrete methods, remember this, having concrete methods in multiple inheritance is always a headache. Whatever ways they give you to resolve is waste only, because it's very difficult for us to trace. C++ will give you support it also. It gives you a mechanism to resolve it also with the help of friendly keyword. Okay, but it is very complicated. Developers will still get confused. In C++, that's the story. Java people did not want to support multiple inheritance. So when they designed the 3 data types, which one? Class, subclass and abstract class, they thought these data types will not support multiple inheritance. That is why if you write class A, class Z extends A, B, C, immediately will get error. Compiler only will report error. You cannot do multiple inheritance with what? Class, subclass, abstract class and all that. So they removed multiple inheritance with these three things. Then developers said, no, we need. So since multiple inheritance was creating complication in other languages, understood the problem now? Since multiple inheritance was causing problem, this is one of the problem. I'll show you with other members. In methods, this is the problem. Okay, so still the problems with variables and all, I'll show you. Since so much problems was there in multiple inheritance, Java thought we'll not support it. But later on, developers did not leave. They said we want. And if the language does not support it, what will happen? People will shift to some other language. They just want reason to shift to another language. So Java wanted to overcome this problem. So that is when they released a powerful data type. Which one? Interface. Very powerful. So initially it was designed with what intention in mind? To support multiple inheritance. But later on, we are using it for setting standards and specification. That I'll explain very clearly next. First see why interface was designed. Then I'll talk about standards and specification. Understood? Is this clear to you? There are two things we have to understand here. Interface was released to implement multiple inheritance. Second thing what you have to understand is how it is used for setting standards and specification. Two things we have to understand. I'm covering the first part. How Java is supporting multiple inheritance with the help of interface data type. Clear? So is this clear? So how does Java overcome the problem of concrete methods? It will not give you only, because there you are having what? Abstract methods. See, if this is interface A, if this is interface B, if this is interface C, if this is interface D, no problem. For all of them, there is only one standard implementation, common implementation. Yes or no? Over. You use it from, that's what I shown you in multiple inheritance. A, B, C. You have three methods. Sorry, three interfaces. A, B. See, this one interface, this one interface, this one interface. Fun is abstract here, fun is abstract here, fun is abstract. So abstract methods are never executed, you know that. Yes or no? Abstract methods are never executed. Now, in the interface, what happens? All methods are abstract. We do it concrete. We do it concrete. When you do the concrete implementation, only one concrete method is solving the problem for all the abstract methods. It's a common implementation for all. Understood? So even though you might be having multiple abstract methods for this, for all the abstract methods, there is only one common implementation. So you will not have any doubt which one is getting executed. Wherever you go, the same method gets executed. From wherever you call, a.fun, same method, b.fun, same method, c.fun, same method, d.fun, same method, z.fun, same method. There's no confusion. It's neat and clear. Which fun is getting executed is very neat and clear. But here it is very difficult to trace. And again you start questioning, why this one, why not that one? Supposingly they give a solution, someone gets executed. Again you will question, why that one? Why preference to that one? Why not to this? Why not to that? Why not to this? Like this will come questions. Then again, if that is solved, okay, from here how will I invoke that? Okay, from there how will I invoke this one? Okay, from here how will I invoke that now? Questions are endless. And it becomes a big circuit now. Never ending solution. And developers will finally get what? Confused. Once developer is confused, he will say in one word, language is difficult. Understood? Now you say C++ is difficult or Java is difficult? C++ difficult now. But what were your intentions? You wanted to learn C++ before Java. I am removing all that from your head now. Understood? So inheritance is very badly implemented. Polymorphism is badly supported. Where? C++. Overloading, operator overloading, headache. Understood? Then next, abstraction. See, overloading also polymorphism problem. Next, inheritance problem. Abstraction. You know how rich Java is there in abstraction. Okay. These three problems. Encapsulation also, partial encapsulation there. What happens? Some code you can write outside the class. In C++, some code you can write inside the class. You call it prototypes now. All that headache is not there. Neat and clean and clear. All code, encapsulate. Abstraction, very simple. What type of an abstraction you want? Choose. Class, subclass, abstract class, interface. You can choose any data type for implementing abstraction. Inheritance, what you want? Take. If you want simple inheritance, multi-level inheritance, hierarchical, go for class, subclass. If you want multi-level, go for interface. Simple. So neatly Java is designing the data types. So it's a refined language. So if you had put all effort and learned in C++, oops, and then come to Java, weren't you really bothered now? You'd have wasted time there now. As simple as that. Instead of wasting that much of time, directly you learn oops in Java itself. That's what I tell. Always you can learn OOPS directly in Java language itself. You don't have to go to learn OOPS in any other language. That's only a myth created in the market by unprofessionals. They don't know what is OOPS properly, and you know how they explain OOPS. Every day I teach you OOPS. Yes or no? Did I say OOPS is over in one day? Today also I am covering what? OOPS. And I will continue OOPS till when? The next 4 months also. What subject it is. Every day it will carry, but with examples. Understood? So anyway, these are the problems with what? Methods. Next we'll see the problem with what? Variables. Or I'll take constructor. Second one I'll take constructor. Then I'll come to other. Or we'll take variables first. First I'll take. No, constructor only is better I think. Second problem with constructor. See, I'll remove everything now. Are you following now? Showing you the problems with constructor now. See problems. Here this is the constructor. Here also there is a constructor. Here also there is a constructor. Now class Z. We'll go with only 3 levels, man. All this not required. When class Z extends what now? They are not related. Class Z extends A, B, C. This is the problem in C++. See all these problems in C++. When you create a Z object now, which constructor should execute first? Tell me now. You are having 4 constructors. One from A, one from B, one from C, one from Z. Which one first? And all the constructors should execute now. And you have to send values. See the flow. So constructors also cause what? Problems in multiple inheritance. Supposingly there is one variable here, int A, one parameter, int X. Here there are 2, int P, int Q. Here there are no parameters. Now what should Z have? How many constructors will it get? To which one will it send? You are just saying ZZ is equal to new Z. But actually you have to initialize how many variables? One in X. You are having one instance variable here. You are having one more instance variable here. But look how the constructors will be invoked. Don't concentrate on variables, concentrate on constructors. Which constructor should be executed first? Which one second? How do you carry values? Full headache. So constructors also cause problems in what? Multiple inheritance. But in Java, multi-level inheritance, you know how the constructors are executed in multi-level. First C will invoke B, B will invoke A. A completes execution, then B will complete, then C will complete. In multi-level it's very neatly organized. There you might be having confusion why they have designed it like this, but now you can see how neatly they have designed it. So in multi-level inheritance the constructors are executed very neat and clean, but in multiple inheritance they cause problems. So that is why interface does not have what? Constructor also. These are all members which cause problems in multiple inheritance. So concrete methods, list of methods, we'll write concrete methods. Okay, concrete methods. Now concrete methods can be what? Static as well as instance. They cause problems. Next, constructor clause causes a problem. Third one, blocks. Blocks, which block? Both static and instance block. They also cause problems in what? Multiple inheritance. If I write block, just see here. In class A I'll write on block, class B I'll write on block, class C I'll write on block, class Z I'll write. Which one should execute now? In multiple. In multi-level it is neat and clean. First A static, B static, C static. A instance, B instance, C instance. Very clear it is. But in multiple, why should A be given the preference? Why should B be given the preference? We have questions. Here preference is given because they are in hierarchy. Correct. But here they are not at all related. Why should it execute from this one first or this one second, this one third? If it executes also confusion. Tomorrow you want to align instead of C. Supposingly if you say A, B, C, A gets executed first. Fine. But tomorrow there will be a requirement. I don't want A to be executed first. I'll change it. But changing is so difficult, you know that. Code will go on changing everywhere now. So it's very difficult to control your code now. So that's why, just understand, you don't go deeper into all this. You get the overview and you don't have to practice in C++ and see the problem now. You just get visualize now. These are the problems with C++ inheritance. Understood? Then so Java also realized all these problems. Then lastly, we'll see it with variables. So concrete methods cause problem, constructor cause problem, blocks, which are the two blocks? Static and instance block cause problems. Well, let's see with variables, instance variables. So these also cause problems in what? Multiple inheritance. So all the members cause problems for you in multiple inheritance. See this. There's a class called as A. This is a class and it's having instance variables. Int P, Q, R, S, T. Instance variables. Now B is extending this. B class is extending that. It will have V, W, X, Y, Z variables. Instance 5 plus 5. Now B class will have how many variables, sir? 10. See, if A has 5 variables, B will have 5 plus 5 is equal to 10 variables. Now C will extend what? 1 second. It's correct only. Just 1 second. This is A, B, C. This is the case. Okay, this is called as diamond problem. Okay, in multiple inheritance we face something called as diamond problem. Diamond problem is all see whatever members you are having here, they give you problems in diamond problem means this is related to multiple plus hybrid inheritance. Okay, both hybrid and multiple inheritance cause problem. Understand that both multiple and hybrid create problems. And this is called as the diamond problem. See this: U, V, W, X, Y. Sorry, which one? Not U. V, W, X, Y, Z. So here you'll have 5 plus 5 is equal to 10 variables. Here I'll take L, M, N, O, P. So here you'll have 5 plus 5 again 10 variables. Yes or no? 5 will come from where? Class A. 5 will come from class C. Here 5 will come from class A. Here 5 will come from class B. Totally 10. Here also 5 from A and C. Totally 10. Now when D inherits B and C, actually D should get how many? 15. But D goes on to get how many? 10 plus 10. 20 variables. If they are instance variables, you get this problem. But if they are static variables, there is only one copy. Understood? So these are the problems with instance variables. These are the problems with instance variables. Are you clear? So that's why this one interface is not supporting what? Instance variables also. So whatever members, see, Java wanted to support multiple inheritance. So since they wanted to support multiple inheritance, they did not want to change the behavior of these three data types. Which one? Class, subclass, abstract class. They left it as it is. The new data type was invented, interface. There they realized what all problems are causing, what all members cause problems in multiple inheritance. They eliminated all of them. Understood? They eliminated all of them and they just kept only two members, abstract methods and static final variables. So these are the only two members which do not cause any problem in multiple inheritance. Are you following this? These are the only two members which do not cause problem. Which are the two members? Public static final variables. See, if it is static, what will happen now? If they are static, D will get what? 5, 5, 5, 15 only it will get. If this is for instance variables. The same you make for this one, static. D will get 15 variables. Difference is that. So that is why whatever problems are created in multiple, Java has eliminated that in the data type called as interface. Okay, and interface supports multiple inheritance by removing all those members. So this is how they designed it. So when they want to invent a data type, simply they will not invent it. They cannot invent it. They put so much of effort and they will invent it. But you expect to understand that in what? One day. Interface, what is there in interface? I know what is an interface. Understood? If I told you before this class, today's class I have taken, yesterday, today, what is interface? Interface is interface. I know what is interface. That is how you behave. And you can see the effort what some people have put to design this data type here. For you to understand what they have designed is difficult. Understood? Why? You only understand now. you actually are overconfident in the subject. You think that you know everything, but fact is you don't know anything. So when you think like that, it's very difficult for you to grasp new subject. Understood? These are the problems. Understood? Your problems. Multiple inheritance problems are there. Your problems are also there. Understood? So anyway, these are all the problems of multiple inheritance. Java is giving a clear approach for this. Okay. So this is how it is summarized now. Okay. And so that's why the only two members. You understood why it is not allowing this? But in interview, do not tell all this. You are not supposed to tell all this in interview. Nobody working in industry also knows all these problems about an interface. It's an extra knowledge what I gave you. Understood? Just tell interface supports multiple inheritance. That's it, over. I'm very clearly telling you. Interface supports multiple inheritance. Why? They have designed the data type. That's it. They have designed the data type in such a way that it supports multiple inheritance. Over. Understood? Because it's very difficult for you people to defend. Can you explain like me there? Impossible. So that's why do not bother about these explanations. Okay, that's what clearly I'm telling you. From interview point of view, what is important, I'll give you now. Okay, only practice that much, by heart, do anything, you'll definitely clear it. Understood? What is difference between that and that? So, are you clear with all the problems? You understood why interface is not allowing all the data types? Interface is not supporting all the members. Clear? Okay, only two members are what now? Only allowed members in an interface. What are the allowed members in an interface? Public static final variables. Public static final variables. Second one would be abstract methods. Public abstract methods. These are the only two, and these two will never create a problem in multiple inheritance for you. Yeah? Okay. More you'll understand. Don't worry. Again, for all these answers are examples, examples, and examples. And you will see thousands of examples in cluster. Thousands, not one, not two. Many examples I'll be giving you. Okay, now let's start seeing the difference between what? Class, abstract class, and interface. Tomorrow I'll go more deeper, but today I'll start off the difference between these four data types with members. What all members are possible in which data type? First, see, the topic is what now? The next topic what we are going is difference between class, subclass, abstract class, interface. So let's start it off with what? Members. First one, in a class you can have what? What are the members you can have? Class A. What members you can have? Variables. What are the variables you can have here? Instance, static. Again, instance can be what? Primitive type, user defined type. Correct? Huh? Means user defined means what? Class, subclass has a relation. Has a relation also is possible. Correct now? Class A can have B as a instance variable. Yes or no? We have seen this. Same way, primitive and these are the members. So when you write a class, remember what all you can have. And next you can have blocks. What are the two blocks? Static and instance. Then you can have what? Constructors. Correct. Then you can have what? Methods. They can be static. See, concrete methods. Only concrete methods allowed here. In a class, only concrete methods are allowed, and they can be static and instance methods. So these are the members of a class. Members of all data type. Members of all user defined data type in Java. Class is over. Next, subclass. You know how to write a subclass now? This is class. This is subclass. How do you write? Class. B. Syntax. This is how you write. What are the members? Same story. Variables. What are the two types? Blocks. See, you don't go much deeper into all this user-defined primitive, but gradually you'll understand. Just understand a subclass can have what? Static and instance variables. Just understand that much. Here also understand class can have what? Static and instance variables. You can have blocks. Only that basic you go through. Again, with experience you'll understand how you can have primitive types and user-defined types. Don't worry much about that. Blocks. Again you'll have what? Static and instance. Subclass can have it now. Then again they can have what? Constructor. Again you can have what? Only concrete methods. See, a subclass, if it is having abstract method, it becomes what? Abstract class. That is different. Understood? So a subclass will never have concrete methods. By chance, if you make your subclass as abstract class, it becomes what? Another data type. Abstract class it becomes. So only concrete methods, that too they can be of type static and instance. Next, which data type? Abstract class. Yes sir. Abstract class A. What are the members? Variables. I just finalize out, right? I'll simply write it like this. Instance and static variables you can have. Just leave it. Don't bother about what? Primitive. It can have, but don't bother much now. So again it can have what? Abstract class. Blocks. Which one? Static and instance. Again, abstract class can have what? Constructor. And this can contain what? Concrete methods. Yes, and they can be static and instance also. Plus it can contain abstract methods also. That's the extra member what it can have. These are the members of abstract class. Clear? And lastly, the members of an interface. How do you write? You use the keyword interface A. Only two now. What? Int x is equal to 5. Int add int x. Sorry. Public static final variables. I'm writing the code there. You can have only abstract methods and public static final variables. That's it. You can have variables. And that too which one? Only static. That too it is what? Public static final variables. Then methods you can have only abstract methods. That's it. So these are the differences. Coming to what? Members. See, this you leave it off for time being. Okay. If you are not understanding this, leave it. So what can a class have? Variables. The variables can be what? Static and instance. What can a class have? Blocks, static and instance, constructor, concrete methods. Similarly here, subclass can have what? Variables, blocks, constructor, concrete methods. Abstract class. That's it. You learnt all this now. Clear? So this is in relation with what? Difference. We are seeing all the differences now. Difference between class, subclass, abstract class and interface. Based on members. Still more differences are there. I'll be giving you one by one now. We just started it. Understood? I'm summarizing till now what you have learnt. Then next, shall I clear all this? Then next, some more very important, precious interview points I'll give you. Just learn them. They'll ask you in interview, what is difference between these data types? You know your answers, but do not answer them. Because they'll say next. If you give answer to that one, they'll say next. Means or we'll get back to you. What will you feel? I am selected. Correct? Oh, I am selected. They told they'll get back to me. Correct? They'll get back. But what will you do? Go do puja. 10 coconuts will break. Nothing will happen. Yeah. See, I'll come back to the differences just a minute. See the interface. I forgot. Just points I had to cover. Yesterday I wrote it down. See, interface supports multiple inheritance. See, yesterday we had covered all this till here now. All this I covered. What is an interface? All this I covered for you. How you design it, what it is used and all. These points you have written it down. See now. The pending points. Interface supports what? Multiple inheritance. One class can implement many interfaces. One interface can extend any number of interfaces. Multiple inheritance is not supported with other data types. Yeah. Then it is used for decoupling, declaration and implementation of methods. It always specifies what a class must do, but not how to do it. It supports dynamic polymorphism. Which one? It means here all interface. Interface supports dynamic polymorphism. It also provides very high level of decoupling and abstraction. Then interface is used for loose coupling. I'll explain this point very shortly tomorrow. Now it is a data type which can be used as an interface to work with an object. Okay, it is because of this feature the data type gets the name interface. Lastly, it is used for establishing user relationship. I'll explain that point also. Leave this. Now let's come back to the differences. Yeah, what is the difference between an abstract class and an interface? Some of your favorite interview questions. Favorite, no? Understand it. These are the differences. Coming to what? Members. What it can, just now wrote it. What it can have, what it cannot have. I wrote it now, just now. Just I'm putting it in a table format for you. Now subclass, if you want to write an abstract, okay. Subclass has to extend class using what? Extends keyword. Here class has to implement an interface using implements keyword. Some of the differences now. Apart from the members. You know the members difference now? These are the members of abstract class. They are the members of interface. Leave that. Second point. Okay, understood. Third point. Abstract class doesn't support what? Multiple inheritance, but the interface supports multiple inheritance. Now abstract class is used for actually what? Doing partial implementation. That is completely open for implementation. It does not contain any implementation interface. Then it supports abstraction to a smaller extent. Abstract class supports what? Abstraction, but to a smaller extent. Interface supports abstraction to a greater extent. Dynamic polymorphism. Clear? These are the differences. Okay, it is used for doing now abstract class, one more point. It is used for doing generalization. Tomorrow I'll teach you this. And interface is used for doing realization. Tomorrow I'll talk on that now. Okay, from OOPS design principles I'll talk. Okay, so then next, when should I use an abstract class or an interface? Next interview question. Immediately when you tell the difference. Okay, answer it depends on the scenario, but you don't tell, it depends on scenario. Just tell. Okay, if you do not want to do any implementation and set the standards or specification for other classes to implement, then choose an interface. But the point is what? If you do not want to do any implementation, that time you'll go for what? Interface. Okay, then second point, if you want to achieve multiple inheritance, you can choose what? Interface. So these are the two strong reasons when you choose an interface. Understood? Tell this in the interview. Now if you want to do partial implementation and set the standards for other classes to complete the implementation, choose abstract class. Finished. Understood? So this is how you have to tell the differences. Next, what is the similarity between both of them? Correct now? Similarity, both cannot be instantiated. Both you can declare a reference variable for both. We have to override abstract methods for both. Yes. Both support dynamic polymorphism. Yes. Both support abstraction. Yes. But abstract class supports abstraction to a lesser extent, but interface supports abstraction to a greater extent. Both are data types provided by Java for implementing OOPS. Yes. Then both are used for establishing user relationship. Understood? Slowly. Any point you don't understand, it will be understood later. But just make a point to get ready for interviews now. Understood? So this is the comparison between what? Abstract class and interface. Next I'll compare abstract class and class. Correct now? You know what are the differences? Abstract class is abstract. Class is not abstract. Over. Don't tell that now. Understood? See this difference. Okay. Abstract class, these are the members. Class, they are the members. Difference is what in members? Class cannot contain abstract method. That's the main difference in members. And it is used for doing what? Partial implementation. Class is used for doing what? New concrete implementation. Code is not there at all. You want to write the code fully new concrete implementation, choose a class. It cannot be instantiated. It can be instantiated. So it supports, which an abstract class supports dynamic polymorphism. Class does not support dynamic. Okay. It supports static. Overloading can be done in a class, not overriding with a class. Clear? But you don't justify all that. You just say it is not supporting dynamic polymorphism. That's it. Now when should I use a class or abstract class? Next question. Answer is there again. Again it what? Depends on scenario. Okay. You should tell scenario 1. Like that you start telling there like a director. Understood? Don't do all that. Tell it something like you are telling it out of experience. Your answer should not be in a by-hearted format. You should talk in such a way fluently that even if your words are here and there, no problem. Communicate. Communication means actually what? making the opposite person understand. It doesn't mean that you should have hi-fi English. Communication means making opposite person understand. That's all. That's actually meaning of communication. So these are the words you use, but I'm giving most clear words, simple words. In books they are very complicated, and I've given it in a very simple terms. So see this, if you want to do new concrete implementation, then choose class. If you want to do partial implementation and set the standards for other classes to complete the implementation, choose abstract class. If you want dynamic polymorphism, then you go for abstract class. These are the reasons why you go for class, these are the reasons why you go for abstract class. Similarity, we can declare reference variable of both. Both have been given by Java for implementing OOPs only. As simple as that. All the 4 data types, they are given for implementing OOPs. Next, your favorite, class and interface. Correct now, all interview questions only. Correct now? Yes, read now. So a class contains what? Attributes and behavior of an object. Yes or no? What does a class contain? You know this definition very well. What is a class? Class contains what? Attributes and behaviors of an object. Correct. Same point. Yes. What is interface? An interface contains behavior that a class implements. It is telling what to do. Understanding the point? Interface tells what to do, but not how to do. That's the meaning. An interface contains behaviors that a class implements. This point clear? No, you understood? This is your favorite point. What is a class means? Class contains attributes and behaviors of an object. Same point. I have not deviated. Your point only I am writing because you have bited for 4 years. I don't want to waste your point. Okay. So next, you can instantiate a class. Yes or no? You cannot instantiate an interface. A class can contain the following members. So many members. You know what are the members of an interface? Go through now. Members. Okay. Then in class, the declaration and implementation of the method is tightly coupled. Yes or no? What do you mean by that? When you write a method, logic is also written for the method in the class itself. Means you give the body for the method. So that is what we mean. In class, the declaration and implementation of the method is tightly coupled. Declaration means giving method name. Implementation means giving body. Writing logic. It is tightly coupled. See there. So in interface what happens? It helps to decouple declaration and implementation of a method. This is really helpful in setting standards for other classes to complete implementation. Class is used for doing concrete implementation. Understood? Interface does not contain any implementation. It is used for setting standards for other classes to complete the implementation. Next, class does not support what? Multiple inheritance. But an interface supports what? Multiple inheritance. It does not support dynamic polymorphism. Interface supports dynamic polymorphism. Clear? Dynamic polymorphism is becoming the big word now. And it continues to be very big as we start programming ahead. Understood? So when should I use a class or an interface? Again, depends on scenario. Yes. If you want to do a new concrete implementation, then choose class. If you do not want to do any implementation and set the standards or specification for other classes, read it now. Same point is repeating. Okay. What is the similarity? We can declare reference variable for both. And both are data types provided by Java for implementing OOPs. So these are the differences between all the data types. I have only not used subclass here. Subclasses are used for adding or changing implementation. Understood? So this is how they have designed the data type. So every data type you should be very powerful, and when you start writing the code you should understand all these points very clearly now. Any questions with this? Still more from the OOPs design principles I will talk tomorrow. Still more differences I will give you. But from interview point of view, this much only you tell. Okay, next what I tell, don't tell. But you will understand it in future. After 3 years in your life, you will understand those points. Not 1 year. After you code in object-oriented language for 3 years, then you will understand the next strong points what I give you. Okay, so do not use them in interview. So I am teaching you Java from experience. Understood? Not book and teach, refer to one book and teach. You think Java is something, I am teaching Java in a different way. Understood? Clear? So just you can make a point of all this. Are you clear? Abstract class, interface. This one, differences. Okay, just you can write down all these differences. Okay, then tomorrow I will tell you some more points. That's it. Okay.